Merci beaucoup, Freddy. Donc, je sais que Carlo a des commentaires.
Well, I think that all what you prepared today is very attractive, but it sounds like a dream, in the sense that a machine cost is proportional to its dimension, and this machine of 100 kilometers, in my view, will find probably a more attractive place, not within the very busy Geneva area, with the lake to be filled, etc., but in some different place. The real question there is that what is this machine for? And this is where I have some difficulty in understanding your presentations and your suggestions and your dreams. First of all, let me say, we have the example of the Z particle. We had two phases in the Z particle discovery. First was the Hadron Collider experiment, in which proton and antiproton, or proton-proton, were used in order to produce the effect. And that was the beginning, and it was the indication that the set was there and so forth. And then there was a second phase, very important phase, done with LEP, in which we have selected the single particle in the S states as a single object, which has permitted to study all the information, gives the real long-range information on this. Now, we have ahead of us a problem. It's called the Higgs particle. John Ellis mentioned the importance of the Higgs particle for the future of science, a standard model, etc., etc. And the proton accelerator, which has been now put together, will do the equivalent of the proton-antiproton measurement of the Z particle. The question is that you do need another additional program in order to be able to study the Higgs particle by itself as a single S state. And this you can do not with electrons, unfortunately, because electrons do not interact with the Higgs particle, but with muons. And there is a lot of work which has been done. I also participated myself on a personal basis to this question. The possibility of building a cooling system which would provide us the possibility to produce with the two colliding beams of muons, only 60 GeV, which would be a very tiny little object which would fit within the CERN system, would provide a collisions between mu plus mu minus at the mass of the Higgs, producing the Higgs mass alone and studying all possible channels, just the same way in which the Z0 was studied with the very successful results of LEP. That seems to me it's a natural next step, rather than dreaming towards making impossible machines which will occupy the Geneva area like it was with this kind of magnitude, with the time scale, which obviously will be much longer and much more difficult, because it is not clear to me how you can study these things without really knowing what you're looking for. Because the why 100 TeV particle, what's the purpose of it? Supersymmetry, will say John, but maybe supersymmetry doesn't exist. And then what else are you going to do? While the Higgs is there, it needs to be studied. And this simple hadronic measurement with LHC is not enough to close the Higgs business, and therefore a muon collider, it seems to me, the proper solution. So, by the way, the trouble with this proposal, muon collider, is that it, unfortunately, or fortune, costs much less. Your dreams of getting you know, a giga dollar, giga euro program to build these things, it's of course also a reason to make it big. It will work. But it seems to me, the physics-wise, a study of a muon collider, it's much closer to reality. It's something you could do at CERN, within the CERN premises, in a relatively short time. And in my view, that's the next step in analogy to what happened to LEP and the P-P collider with the Z particle.
Tu veux commenter ou?
Je vais commencer à commenter sur l'aspect accélérateur. Après, je te laisserai, John, commenter sur le pourquoi de la physique, qui est plus ton domaine. Je suis tout à fait d'accord avec toi, Carlo. Il faut regarder toutes les options. On regarde technologiquement l'option proton, qui est dans la ligne, comme j'ai montré, la roadmap de faire des aimants à de plus en plus haut champ. La la plupart des recherches et des coûts pour la recherche, le R&D, on est obligé de le faire pour avoir le high luminosity LHC, donc de passer à ce nomium 3 états. Donc, et je pense qu'après, alors moi, on a reçu aussi, comme j'ai dit, de l'European Strategy, de regarder comment, avec ces aimants au champ, on pourrait faire. C'est une étude, et tu dis, on ne sait pas où est la supersymétrie, bien sûr qu'on ne sait pas. C'est une étude qu'il faudra avoir prête pour 2018-2019, au cas où on en a besoin. Et je suis tout à fait d'accord avec toi qu'il faut regarder les muon colliders, mais les muon colliders, ça a des défis au niveau de l'accélération avec la durée de vie des muons. Il faut continuer la recherche, ce qui est sur les LINAC supraconducteurs, rapides à cycle rapide, puisqu'il faut regarder un certain nombre de choses pour pouvoir pas perdre les muons avant. Donc je pense qu'il faut regarder aussi des accélérations plasma. Il y a un certain nombre de choses qu'il faut regarder. On le regarde au niveau accélérateur avec nos collègues américains de Fermilab qui ont un projet d'études aussi. Je pense que c'est vrai qu'il faut peut-être identifier ces études et l'avoir en parallèle un certain nombre de cartes qu'il faudra choisir à partir de 2018-2019 en fonction du résultat du LHC. Pour la partie physique, je vais laisser John répondre.
Yeah, so I agree with what you said, that one needs to consider all the various different possible options. I mean, I think I would make a couple of remarks. One is that actually you can study a Higgs boson with a surprising amount of detail in a hadron-hadron machine. And I think already the first run of the LHC shows what sort of thing you can do. And with the LHC at higher luminosity and energy, and also with the VHE LHC, I think one could make much more detailed studies. It's a different situation from the Z boson, which is perhaps more technical discussion. And I think the other case for going to very high energies is that you open up the phase space for producing other heavier particles beyond the standard model. And this, unfortunately, is a limitation of lepton colliders, both the muon collider that you favor and also electron-positron colliders. I didn't say that. I didn't say that.
So, how many people are doing research and development on the muon collider at CERN?
For the time being, in
Zero.
No, not zero. We have
Me, yes.
No, of course. Mais on a 3-4 personnes qui regardent pour l'instant, et j'ai l'intention de lancer plusieurs personnes pour regarder cette étude en parallèle.
Ça me fait un plaisir de rencontrer ce monsieur aussi vite que possible.
D'accord.
Okay, there's another question over there.
No comment on what Carlo said. I think there is. I totally agree with him that it's fundamental to study the Higgs particle in utmost detail. But you said we cannot do this with the plus or minus collider. This is not totally correct. I mean, there are very interesting programs to study Higgs in a lot of detail with the plus or minus machine as well.
So I think it was a misunderstanding. I said the limitation of E plus E minus is producing other particles.
Yeah,
yes,
Carlos said you could not do that with the plus or minus. So I hope that a realization of an E plus E minus machine in a short time, say a few, let's say 5, 10, 15 years, will be able to go along the direction you mentioned to produce more information about the Higgs.
Please.
The point is that E plus E minus can produce the Higgs, but in association with something else. It's not possible to produce the Higgs alone because as you well know, the branch configuration is proportional to the square to the mass. Therefore, it is true that E plus E minus will produce Higgs, but the Higgs produced by E plus E minus will be not different than producing Higgs with proton-proton, because it's a complicated final state channel with a lot of extra particles. And therefore, it will be dominated by a large amount of backgrounds. This, if you don't know that, I mean, we'll not be able to discuss it, but I mean, this is the situation. While in the situation of the Higgs, by the way, the Higgs has a very narrow width, is a width of only a few MeV. So therefore, you need a very specific system in order to identify its width. Certainly, to the Higgs is a fundamental question. and the measurement of the Higgs, the width of the Higgs, will not be possible with any plus or minus machine.
Okay, I think that in the interest of keeping to schedule, we'll just take one more question. Eliezer.
Well, it's a comment on what I think it's very appropriate that here on the Iberian island, we are discussing if to build our favorite ships to reach continents which we know, or to build ships which will just cross the ocean to places we don't know. That's it.
Okay, well, thank you for that. So I think that we'll close this session now. It's time for a coffee break, and we'll be back in 15 minutes.